Welcome everyone to today's webinar, How to Design a Fuel Oil System for California. I'm joined by Lee Carnahan. He works in California and designs fuel systems for the California market. He's been doing this for over 13 years and he has a very in-depth knowledge of the fuel oil systems and how they work. Thank you, Lee. Really appreciate you coming here today. Take it away.
Hey everybody, thanks for coming. Appreciate you guys being here. This is designing a fuel oil system for California. We're going to go over several things particular to designing and installing a system in the state of California. By the way, this presentation will be posted to the Preferred Utilities YouTube channel as soon as possible. And if you'd like to have it in PowerPoint or PDF format, go ahead and email to us and we'll go ahead and email it back to you. As you know, my name's Lee Carnahan and I'm the district manager for the Western region for Preferred Utilities. And our office out here in California specializes in diesel fuel oil handling systems. So that's basically all we do. We have a full-time technician out here as well as a full-time California fuel oil designer, as well as all the support of all the good people back in Danbury, Connecticut as well. Our topics today are going to include Assembly Bill 2481, some specifics about Assembly Bill 2481 for California, also State Water Resources Control Board and their particular requirements. We're also going to discuss design requirements for OSHPD, which we're going to talk a little bit about in more depth as well. And then we're going to move on to discuss particular rules and requirements of both San Francisco and Los Angeles. A lot of their requirements are very unique and specific, so we're going to go into some of the main requirements that those cities have. California Assembly Bill 2481, or AB 2481, basically I just got this information from their internet webpage just to explain what it is. Their charter it establishes a new, more stringent set of requirements for UST systems installed on or after July 1st, 2003, obviously sponsored by the California State Water Resources Control Board. And through the summary that you can read on the screen there, strengthens and reorganizes the law related to underground storage tanks in order to protect the environment against unauthorized releases of petroleum, including MTBE. I'm not going to go through that. Obviously, as you can see, AB 2481 was directed at retail gas stations as well as commercial and industrial sites. So it's not just for us, it's for basically everybody. A little more particulars on California AB 2481. In the interest of completeness and to make sure nobody at the SWRCB gets upset, here are the listed goals of AB 2481 in their completeness. However, we're just going to focus on the points that apply to our systems, which are the items in bold. The first one requiring new USTs installed after July 1st, 2003 to be liquid and vapor tight. Always a good idea. Skipping down to number 4, requiring licensed tank testers to prepare a report on each tank or piping integrity test they perform and assign the report under penalty of perjury. Makes sense. Number 5, modifying the enhanced leak detection testing requirements, including a one-time testing requirement for double wall USTs within 1,000 feet of a public drinking water well. These requirements of the enhanced leak detection, or ELD, have actually changed over the years. They're a little bit simpler now. They can just do a pressure pipe test. What they used to have to do before is lay out a special PVC piping system that with sniffer pipes in the shadow of the UST and actually sniff those, put a specialized gas in there and then sniff the ground. That is no longer, that test method, excuse me, is no longer used. Some of you might have remembered the Praxair tests of 10 or so years ago. That method is no longer used. So these methods have changed as well over the years as far as some of the test methods themselves. Skipping down to number 7, clarifying that all secondary containment components that are part of an emergency generator system, as opposed to just under dispenser containment or spill containment or control system, may be tested using enhanced leak detection. So, in other words, not just gas stations, this is for everybody now. Those are some of the main points for AB 2481. Some more specifics about California Assembly Bill 2481, UST requirements. I'm just going to run through some of these real quick, and some are more important than others. So, number 1, the law requires new tanks be double contained. Number 2, both primary and secondary containment must be product tight, of course. Number 3, water intrusion must be prevented, of course. Number 4, secondary containment must meet specified volumetric requirements. This is going to vary so much depending on the project, site, or type of project, or specific requirements. A lot of times you will see 150%. That's why I put the example in the parentheses there. But it could be 110% for secondary containment. It could be 200%. And those items actually being contained can also vary. We've seen even catch basins for fill risers, that sort of thing. So we can get into some more of the specifics a little bit later, but that can actually cover a lot of things. Number 5, the tank must have a continuous leak monitoring system. That means 24/7, 365. Number 6, pressurized piping must be equipped with leak detection. This means a couple of things. It can mean programmable line leak detection. It means also vacuum monitoring system on pipe secondaries and underground piping. So what they're referring to here as far as pressurized piping, I think, is an important point to make, and that is normally with USTs that's going to be a submersible turbine pump. That creates a situation where, by definition, the entire piping system is essentially pressurized all the way to, theoretically, to the day tank. The only way to not have a quote-unquote pressurized piping system in a UST is to use positive displacement pumps placed above ground, and the underground piping portion is actually the suction line before the inlet of the pump set. And if that's the case, with a UST system, a different set of rules applies. And they're actually quite a bit simpler. Number 7, the tank must be tested using enhanced leak detection and inert gas pressure test or equivalent test measures before it is placed into use. Again, I had discussed the former ELD method that is no longer used. This changes periodically, but these days it's quite simple. Pipe pressure test, special gas is often used, and the piping itself and the secondary can be tested with those particular methods. A few more points on fuel oil handling system requirements of AB 2481. Again, the important ones to us are in bold. The first one, AB 2481, requires that tank spill containment structures be tested annually. That's commonly known as an annual CERT. It needs to be done by a certified technician, and by certification, that is state certified, not factory authorized, that kind of thing. So those are commonly referred to as annual certs. The second thing is that AB 2481 requires that owners of tanks within 1,000 feet of drinking water wells take action to fix the problem when enhanced leak testing shows tank leakage. This is often why a lot of sites have SPCC plans done prior to the installation of the system. SPCC plan, for anybody who hasn't heard of one, is a spill prevention, control, and countermeasure plan. And these can be quite in-depth, calling out locations of local rivers, schools, runoff drains, etc. So these can be quite complicated sometimes. And if anybody needs to or wants to learn more about those, give me a ring. I have some experience with those as well. But that that's a lot of times why people have SPCC plans. This is just a kind of a quick slide to show a couple of the types of tanks that we're going to encounter out there that have to comply with AB 2041. They're composite USTs and double wall fiber reinforced plastic USTs. The way you can tell them apart at a quick glance is composite USTs, which are FRP over a steel primary inner tank, is that they have flat ends. Double wall FRP tanks actually have rounded ends. So that's a quick and easy way to identify them. There are actually differences in the equipment for measuring the liquid levels inside as well. The controls actually need to compensate for those rounded versus flat ends. So it's a little bit more complicated than it looks, but that's a quick and easy way to identify what type of tank it is. California Assembly Bill 2041, as we've talked about, has different requirements for the tanks, the different tank types, and the pumping systems. For this slide, we're going to talk a little bit about the suction system basic continuous monitoring requirements. As far as double wall FRP tanks go, generally their tank interstice between the primary and secondary tanks are filled with polyglycol, or what's often referred to as brine, with hydrostatic monitors. Double wall composite tanks, on the other hand, with the steel primary FRP outer tank, usually have an interstitial leak detector, preferably discriminating, so you can tell if there's water intrusion or there's actual fuel leaking out of the primary tank. And those are usually under vacuum as well, the secondary on the composite tanks. So a little bit different there with suction systems between the two different types of tanks. As far as UST transition and vent sump monitoring, polyglycol hydrostatic interstitial monitoring is used there. As long as the polyglycol is in stasis at the same level in the sensor, everything's fine. That means there's nothing leaking in, there's nothing leaking out of the interstice. As far as underground pipe monitoring goes, polyglycol interstitial monitoring is approved, or vacuum monitoring, even if you're not using a pressure system. So we need to make the distinction here that vacuum monitoring is required on pressurized UST systems. However, it's optional on a suction system. California Assembly Bill 2041, in reference to pressure type systems, requires also continuous monitoring, of course, and there are some differences. So as far as the UST itself goes, a double wall FRP, same tank monitoring there, hydrostatic, and there are actually a few double wall FRP tanks that are capable of vacuum monitoring if you wanted to use that, but not all. So I would exercise caution in specifying double wall FRP with vacuum monitoring because it depends on the manufacturer and the type of tank. As far as double wall composite tanks, you're going to use continuous vacuum monitoring system. For UST sumps, transition sumps, and vent sumps, essentially when I say UST sumps, by the way, I'm referring to tank risers and the actual tank top sumps. So as far as all those types of sumps go, those are all basically going to be polyglycol hydrostatic interstitial monitoring. For the underground pipe monitoring, this is a big difference here. You're going to want to use continuous vacuum monitoring for a pressure system. And there's an example there of some floats that are used for the continuous vacuum monitoring system. If anybody has questions about the system, we can address those offline. Preferred Utilities has, in fact, just developed our own vacuum monitoring system with the floats and an actual onboard air pump, etc. So it works a little bit differently, and a companion magnetostrictive level sensor for the main tank as well. Those are complete and are actually for sale, but are awaiting California State Water Resources Control Board approval. So we need to get on the matrix. So a little bit more on the California State Resources Control Board. The main thing to get out of this slide here is that the SWRCB publishes a matrix of approved systems for new tank and piping installations. This is known as the matrix in California a lot of times. And the last update was April 25th, 2014. Any equipment used on an underground system needs to be approved on that matrix. So we are actually in the process of getting approval to be on the matrix with our products, and hopefully that'll happen shortly. The type of system that you'll typically see in the field now is similar to one that's in the photo there. That's a preferred panel on an underground system with a Vita root that is actually running the vacuum monitoring as well as the tank level. When you're using the vacuum monitoring system, you need to use the magnetostrictive probe that goes along with it. So in this case, that Vita root panel is monitoring the vacuum and the main tank level. The actual control panel next to it is running all the leak sensors and all the pump controls, etc. So this is a fairly typical system you'll see in the field now. This particular system was at a 2N redundant data center, and that panel and the Vita root, there are twins next door in the next room that are absolutely identical for a second UST because of the 2N redundancy. So it's just kind of an interesting little tidbit there. This is the SWRCB pipe monitoring matrix. As you can see, this is page 1, and basically this is just a listing by the SWRCB of approved products for pressure and suction systems for underground storage tanks. So it's important to be on this list. In fact, it's required in order for installation on a new UST. So we're always checking to make sure that everything is on this list. Of course, we know the list pretty well because, as I said before, it was published on April 25th, 2014, and that's the last latest update. We're hoping to get this updated with our own stuff shortly here. So this is just page 2 of the SWRCB pipe monitoring matrix. As you can see, there's Brugg piping on there, Omega Flex. We tend to use a lot of Omega Flex double track. It's just a really good product. And Brugg is an excellent product as well. There's just a little pricing difference between the two, but both are approved and great piping systems. Now we're going to talk a little bit more about OSHPD, which is the Office of Statewide Health Planning and Development. Basically, the important point to get out of this slide is the bolded bullet point there, which is OSHPD also monitors the construction, renovation, and seismic safety of hospitals and skilled nursing facilities and provides loan insurance to assist the capital needs of California's not-for-profit healthcare facilities. What this means is when we're designing a system, we have to not only follow federal and state requirements as well as local, say, city and county requirements for USTs, but we also have to follow OSHPD rules. And this also applies, of course, to AST systems. OSHPD has a lot of their own specific rules and requirements for things like capacity and seismic safety, and we're going to talk a little bit about some of those OSHPD requirements. So here we have several points on OSHPD approval of actual equipment. The first thing is Seismic approval can be achieved through special seismic shake table testing. We've had the chance to witness this ourselves on some equipment a couple of times with some of the other preferred employees here in California. It's actually quite interesting, and they really do try to shake the equipment apart. It's quite violent. You would not want to be on the table with the equipment. It's very intense shaking and very fast shaking, very vigorous back and forth shake movements. So on different axes. So it is quite violent. Acceptable test results can lead to OSHPD seismic pre-approval, or OSP. What that means is the equipment is already approved for installation. It's not before approval of the equipment. It's actually the equipment is approved, pre-approved for installation at the site. So it's nice to have OSP numbers. And as an example, I've put our online listing there. They can all be looked up online if you're curious about who sells what and what is approved. Our number is the same across all of our products. So if you have our OSP number, you want to list it in a specification, that type of thing, it is one number. I'm not sure that will always be the case as far as OSHPD approved equipment, but so far it's one number. Some equipment certifications can be bookended. What that means is if you have a product that has different sizes, you can take the biggest size and the smallest size, and all the sizes in between are also approved as well. So some certifications are a little bit easier to do like that. All preferred utilities controllers that we manufacture and sell are approved under OSP, as well as our model PF505 fuel filtration cabinet, which is pictured to the right there. That's usually going to be the only unit that an OSHPD hospital is going to want, so that's why that's the unit that is approved. If you do have a smaller tank, for example, it just means you'll have to clean it less often, so it'll work anyway. But there are probably not very many OSHPD hospitals out there with, say, a 2,000-gallon tank, so that has worked out very well. Also, not all equipment must be shake tested and approved. Some equipment is deemed durable and seismic requirements do not apply. An OSHPD inspector will be able to advise as far as which equipment needs to be approved and does not, but generally we have a pretty good idea of it. Also, there are zones as well. So sometimes there are locations on projects where normally a piece of equipment may need to be seismically shake table tested, but if it's outside of the seismic zone, then it will not need to have the certification. So there are some exceptions to the rules, but generally there you have it as far as seismic shake table testing approval for OSHPD. So these are a few OSHPD guidelines and requirements when we're planning a project with you. Following features are really things that we need to look out for in addition to the federal, state, and local requirements. First thing is we want to, of course, make sure that we're using equipment that has OSP approval. So control panels, filtration systems, and day tanks, we want to make sure the OSP approval is there for those items. We want to also have seismic data and calculations for any stands, stanchions, anchors, etc. Our equipment, pre-approved, is pre-approved based on, usually in the case of control panels, they're wall mounted or mounted to the equipment. If there is a variation on that, then there needs to be seismic data and calculations shown to the OSHPD inspector. 72-hour minimum generator runtime, I believe that's pushed out to 96 hours soon in a number of years. It's approaching, and I can get more specifics on that. If anybody's interested, just email me. Total fuel storage should be a minimum of 133% of the necessary or usable fuel in the system to achieve the minimum runtime. So we'll calculate out the minimum runtime combined with the actual available or usable fuel, not the nominal capacity of the devices, but the actual usable fuel, and make sure that that's at least 133%. That ensures that there's enough for the minimum runtime, as well as fuel for exercising generators, testing, that sort of thing. We're going to, of course, encounter OSHPD inspections by OSHPD inspectors, in addition to local and state local authority having jurisdiction inspections. So you have another layer of inspectors and inspections on your project. So want to make sure we got all our ducks in a row there. And one of the particular rules and one of the primary things that we look out for when we're designing a system is the physical separation of emergency generator fuel from boiler fuel. So if we're assisting with a system that has both boiler fuel and generator fuel, there has to be that physical separation. It can be in the form of separate fuel tanks, which is very common. We can have compartmentalized tanks, especially in situations where there's maybe a lack of available real estate to put a tank. Another way that we can deal with that, especially on retrofits or older systems, is we can use short boiler suction drop tubes or short turbine pumps, so the actual pickup location of the fuel is higher and is up high enough at a level in the tank that it does not have access to the rest of the fuel below it. And that rest of the fuel below it, and this is a very important part of this situation, that generator fuel available below it has to be enough to run the generators at their minimum runtime. So we can't just have short pumps. We got to make sure that those pumps have enough height installation location on them so that the fuel below can run that minimum generator runtime. So that can become a little tricky on retrofits. Basically, a good rule of thumb here is to clear any solution with OSHPD prior to finalizing the project, or at least a design phase. It's really, you don't want to go down a road and say, well, this is allowed. It may be allowed in one situation or one location and not in another. So you want to get the approval with OSHPD up front before you go too far down the road with design. Now we're going to get into some specifics about San Francisco and then, of course, Los Angeles. But starting out with San Francisco, I actually want to start this slide with the bold italic note at the bottom of the slide, that there are more requirements, some written, some not. Chances are we have encountered any requirements that come up in your projects. That's usually the case, but I think it's important to note that before going into this slide, that there are a lot of requirements, some written, some not, and this is by no means a complete list of things that you're going to run into in San Francisco. These are just very common things that we'll do on every single job because we know about these, but different things can pop up at different times. So with that in mind, these are some points here that you want to plan the project around. So the first one being remote fill ports. Standard fill port usually has a single warning light. In San Francisco, they require two fill warning lights, one at 90 and one at 95%. That first light goes on at 90, and then of course the second light goes on at 95%. That one's unsilenceable. You can silence the alarm horn, but not the light. And that just, of course, is signaling the driver. So we have those two lights instead of the typical one in San Francisco. Second point here, remote fill ports, is the common leak alarm light. Normally not required in the state, but in San Francisco they require a light at the remote fill panel that will show that there's a leak anywhere within the entire system, even on the roof. So we need to include that as well. Sometimes in San Francisco, we have encountered situations where they've required 4 tank vents for tanks that are indoors. And have also encountered the last point there, which is all vents run outside the building to terminate, um, versus other areas where weighted pop-up emergency vent caps are allowed indoors. So when dealing with vents in San Francisco, it can be a little different than is allowed in other locations, including running not only 3 but 4 vents and running them all the way outside. Those vents all, of course, need to terminate 12 feet above local grade. So there are a few more San Francisco specifics that we want to go over real quick. Again, these are things that we've encountered but aren't necessarily required on every single project. But these are actually quite common on this particular slide. So the first one being aggregate UL 142 tank capacity of 1320 gallons per building, and that is an aggregate maximum. So that means every tank in the building added together, bulk storage tanks as well as day tanks, added together can't exceed 1320. That's not to say that we haven't seen more or gotten approval on more, but it's a fairly common thing that comes up on some of these projects. Next item is all piping is double contained throughout the system. That's pretty much on every project, so that's definitely something to plan for. Next item, fire rated soffit for fuel carrier pipes. Same thing here, essentially required on basically every project. We tend to see 2-hour rated soffit requirements. I have heard people talk about 3, but I don't think I've encountered any of those personally. Next item is a little bit more complicated, and that's a capture basin for fill riser contents. Say in the case of a primary pipe failure on a remote fill system, more commonly a boosted remote fill system. So a system that goes up, say, over 5 or 10 floors where there's a good amount of fuel in the carrier pipe. We have had this requirement given to us by the SFFD, and it's usually handled with a containment basin, usually a rupture basin from a day tank. We can terminate the pipe secondary in the basement or wherever the fill port is, and wherever the low point in the piping is, that is to say, and basically calculate the size according to the contents of the fill riser pipe. It's not a situation where they're concerned about the tank siphoning out. It's just the contents of the fill riser pipe. So we have dealt with that several times. Last item here is recovery of the fuel riser fuel, which is a dry fill pipe situation. We have not had this enforced yet. The engineers have managed to get approval without this. However, this has come up a few times. In fact, there are 1 or 2 right now that that has been suggested. This is problematic because it requires quite a bit more complex of a system. But the most problematic aspect of this is that in order to recover that fuel, it is going to have to be contained by the owner of the building. Once it's contained by the owner of the building, it can be pumped and used in the system later. But that means that it needs to be contained in the meantime. The reason is because most truck delivery operators or owners will not allow customer fuel back into their trucks. So if we, for example, were to hook up to a fill port and push fuel up to a roof, and then there's 80 gallons of fuel in that fill riser pipe in a high-rise building, and they want a dry pipe, it's theoretically possible for the truck operator to hook up to a different fitting that doesn't have a check valve, and turn and reverse his truck pump and pull the fuel out of the riser pipe. Of course, that would require some designing to do that successfully, a vacuum breaker, etc. But all that said, most trucking companies, delivery companies, will not pull fuel from a customer site back into their truck because it could be contaminated. It'll contaminate the rest of the fuel in the truck. So that's the biggest reason why this is a problematic type of requirement. And again, thankfully, we've never had it enforced, but we have had that request. So if anybody would like any more information than that, go ahead and give me a call or shoot me an email, and I'd be happy to answer any questions about that. So now we're moving on to Los Angeles, and one of the biggest issues that we deal with in LA is the 60-gallon day tank rule. And anybody used to working in the city of Los Angeles on these systems is well aware of this. Basically, the tanks are limited to 60 gallons, regardless of generator size, bulk storage tank size, etc. This is not something that we have been able to get around as far as a rule. We always need to deal with this particular issue. So this is a big one in LA. Some of the things that can arise on the project design are potential thermal issues with the day tank fuel, especially on larger generators. Generators will flow quite a bit of fuel, and they tend to return about 2/3 of it back to the day tank. When that fuel is returned back to the day tank, it could be returned a little hotter than the fuel that was in the day tank to start with. So as time goes by, the fuel in the day tank can actually rise as far as the temperature goes, and start creating issues on in situations like hot days, etc. When the temperature does rise in the fuel, the performance of the generator will actually degrade over time as well. So we want to keep the fuel as cool as possible, and 60-gallon day tanks, being so small, can exacerbate that situation a little bit. We also can run into foaming issues. Again, depending on generator flow and consumption, fill rate requirements, this will tend to happen on larger generators where we really have to move a lot of fuel into that small area in a short amount of time. That can create foaming in the fuel, which can actually cause the level switches in the day tank to give false readings and basically send alarms or errors to the control panel. So it's another potential issue that we want to try and avoid there. It can also complicate fuel delivery in larger systems. When we have fuel that needs to go to multiple day tanks on especially large generators, we need to get it there in a hurry. So we have high flow pumps, large piping headers, that sort of thing. When the headers branch off into the separate generators, if we have, say, 10 generators and only one of them is calling for fuel, that one day tank is going to get the full force of that piping header and those big pumps. And we really don't want to fire hose fuel into a small tank because of the aforementioned issues. So what we do is install flow restrictors to restrict how much that fuel inlet into that day tank can actually move the fuel. That way we can try and mitigate somewhat the potential foaming issues, etc., of delivering that fuel to the day tank. So this drawing is here to illustrate how we can mitigate the fuel temperature climbing issue in the day tank. And the way that we can do this is to reconfigure the piping so that the generator is not just pulling fuel from the day tank and returning it back to the same day tank, but in fact to return the fuel directly from the generator engine to the main bulk storage tank, or tanks in the case of the drawing. So what this allows us to do is actually send the hot fuel back to the main tanks and continuously supply the day tank, and therefore the generator, with the cooler fuel from the main bulk storage tanks. The catch on this system is, should we go down this road and decide to reconfigure the piping in this manner, then we need to keep in mind that now we are pushing fuel through the system at the generator flow rate rather than the generator engine consumption rate. The flow rate can often be 3 times higher. A lot of times the generator will only burn off about 1/3 of the fuel that you're supplying to it in order to use that fuel to cool the fuel rails, as we discussed previously. So now we're in a situation where we're sending the fuel directly from the engine back to the main tanks. That means we have to upsize our pipe and upsize our pumps potentially to accommodate moving up to 3 times as much fuel as we previously were. So that's something to keep in mind, and it's something that we would go over with you during the design process. So another issue that we run into in Los Angeles is the pump activation on gen run rule. And that is basically we can't run the supply pumps unless at least one generator engine is running. So what this means, if we start going through the bullet points here, is the first one, supply pumps can't circulate or exchange fuel through the system periodically for fuel filtration or polishing unless there's a generator running. So that's pretty inconvenient when we want to, for example, periodically turn over the fuel in the day tanks with the fuel in the bulk storage tanks in order to get that fuel polished. So that day tank fuel is basically going to remain in the day tanks until the generator burns it. We'd rather exchange that fuel and get it polished. Second bullet point here, supply pumps cannot circulate fuel. For example, when the fuel is at an elevated temperature, as we were talking about previously, we can have a sequence that we like to call a thermal exchange sequence that will actually, once again, turn over the fuel, say in a day tank that might have fuel that's over a certain temperature threshold. We want to circulate that fuel with the bulk storage tank oil in order to cool down the fuel in that particular day tank. We can't do that unless the generator is running. Thankfully, in a lot of cases, the generator is running when this is going on, so that may in fact be possible even while the generator is running. So this isn't necessarily a big problem, but if we have day tanks sitting up on a roof, we might like to cool them down before the power goes out, because everybody turned on their air conditioners in Los Angeles at the same time. That's when the power is going to go down in Los Angeles. Another point here is supply pumps cannot run a prime check or prime maintenance sequence unless a generator is running. So periodically we may have a program in the controller that says once a day do a prime check and a prime maintenance sequence. So it'll fire up, make sure that there's flow. If there's no flow, send an alarm. Somebody can go over and manually prime the system. If there's no alarm, the system will go through its prime check sequence and go ahead and move some fuel, purge any air, etc. anyway. So there is a maintenance aspect to that sequence as well. So some of the solutions here, obviously installing a priming T-assembly is a good idea in a suction system where you may lose prime, as we were just talking about. That basically consists of a T fitting, a ball valve, another piping nipple and a cap and a funnel. It's pretty simple. If anybody has any questions about a priming T-assembly, go ahead and email me or call me, and I'd be happy to help you with that. Another way is to design with submersible turbine pumps in situations where prime loss is a higher risk. That way there is no priming issue whatsoever. You've got a fully pressurized system. And another option is to go ahead and design the filtration system with an onboard pump, even on a UST system, that has its own dedicated piping loop, which is what we always recommend anyway. And that hopefully will get approval if you request a variance. You can say, hey, look, we've only got this short amount of piping to and from the filtration unit. That's the only place it goes. It's not a supply pump. It's just a fuel circulation pump with the main tank. Hey, if we put a big spill tray underneath it, leak detectors, can you allow us to at least just run that? That way we can at least have filtration on the bulk storage tank or tanks and still be following the supply pump generator run signal issue. So those are some of the issues, some of the solutions. Of course, there are others, but those are probably the big ones for that particular rule that they have in Los Angeles. All right. Well, thanks everybody for participating in this, and we can go ahead and take some questions. If you'd like to go ahead and list them, or in the chat section, or go ahead and email them over, that would be fine. Um, let's see.
Hey, Lee, I think we got a question from someone. It says, get it real quick. It says, hey, you mentioned that above ground piping to emergency generators does not need to be double walled. What are the requirements for double wall piping inside of buildings in California?
Okay, that's going to depend on the location and the particular location of the project. So there are some pretty safe bets in the city of Los Angeles and certainly San Francisco. There's going to be double contained piping within the buildings. Some other areas, outlying areas, non-urban settings, you can submit on single contained piping, and a lot of times get approval for that. So it's really project dependent and location dependent.
Excellent. Just do another one here. It says, so Los Angeles, you can't run a fuel polisher when the generator isn't running. Seems counterproductive. I don't know if that's a question or a statement.
Yeah, and this is something that I do want to explore a little bit more in depth, because it's really not a supply pump. So that is my understanding of it currently. And I'd like to speak to somebody more specifically about polisher pumps in particular to clarify that. But yeah, as far as my understanding of the rules right now, that's not really possible. No pumps, no pump operation. So
Interesting.
Yeah.
Interesting. Let's see if there's any other questions. If anyone in the chat has any other questions, we're more than willing to take them. I don't know, Lee, if you see any trends in the fuel market in California that you like to speak to, that maybe some difficulties that are rising other than not being able to run pumps to your fuel polisher.
California is probably is certainly amongst the most stringent states in the country, if not the most. I know Hawaii has a lot of specific rules as well. I think there are some things coming up down the road. For example, mandatory replacement of fuel storage tanks after a certain number of years, regardless of condition, that sort of thing. So there are a lot of other things that could potentially be added to the mix in the future. But a lot of the actual technology hasn't so much changed. It's really just making the existing technology a little bit safer. Those are usually, most of the changes that we see over time. So, your guess is as good as mine at this point. I think, everything pretty much is double contained for the most part. Certainly everything underground is. And as long as we can avoid contamination of soils and waterways and that sort of thing, that's really the bulk of a lot of the legislation. Having a leak above ground is a lot of times contained by the building itself, so it's just a matter of hazmat and cleanup. It's not really an environmental disaster in most cases. So
Excellent.
yeah.
So would you just explain to our listeners real quick? We came out with the magnetostrictive probe earlier in this month, and also the vacuum leak detector. And can you just explain to our listeners, those that are online, a little bit about those products and where they can find the information about them?
Sure. The information's on our website. We do have, or you can email me directly and I'll send it to you. We do have those products actually available now. They are brand new, and they're a little bit different from what you're used to seeing there. On the existing UST systems, most of them installed in California right now. The vacuum for the vacuum monitoring system is actually generated by the submersible turbine pump. In our case, we actually have a vacuum pump on board the system, so we don't have to run the pumps in order to generate that vacuum. So that's probably the most fundamental difference between our system and the others currently available. The systems do, as I said in the presentation, need to be approved by the state in order to be installed on these UST systems per AB 2481. But we're working on that, as I mentioned, and not sure exactly how long of a process that is, although from seeing an interchange between our Vice President of Engineering and the State Water Resources Control Board, they were very responsive. I think it was within an hour. So that was impressive. So we wish him the best in his efforts to get those approved as quickly as possible. So again, they are available right now, but I'm not going to recommend specifying them on any projects until the approval comes through, and then all bets are off and it's gangbusters after that. So it's a very good system. So.
Yeah, excellent. Well, let me see if check the chat.
I will mention one more thing on that. Our new magnetostrictive probe is available in a rigid format as well as a flexible. So that I don't think was mentioned. And I think we're the only ones that, and correct me if I'm wrong, but I think we're the only ones with a magnetostrictive probe that has an optional temperature sensor option as well. So it's kind of unique. But, those are new products.
Yeah, definitely. Well, there's two new products that we have coming out in the fuel market, and if someone has any questions about them, feel free to contact Lee. Lee, do you have any closing comments or something you want to tell the audience before we sign off here?
I would say if you're working on a project that's within one of these topics, AB 2041, underground systems, or specifically San Francisco requirements, LA requirements, etc., don't hesitate to call us or email us anytime. That's primarily what we do in this office is assist with engineers on projects, and since this is all we do, we're pretty familiar with a lot of the requirements and the calculations, etc. So hopefully we can save you some time and some headaches, and get some good designs out there.
Yeah, excellent. Okay. Thank you very much. I really appreciate the opportunity for you to speak, and thank you for all the information. Once again, if anyone has any questions, feel free to email Lee. We'll leave his email up there for a little bit in case anyone's still trying to write it down. His cell phone number is there, and feel free to give him a call and reach out to him and ask him any questions you have. This presentation will be posted on our YouTube page, so if you basically immediately, so if you want to, go ahead and check it out there on our YouTube page. So it would be YouTube and then search Preferred Utilities, and it'll be posted there relatively soon. And hope everyone enjoyed and learned something, and thank you, Lee.
All right, thank you, everybody, and thanks, Mike.
Yep.
Take care.
Take care.